Okay, I'm going to talk to you about Lua, which is a programming language you may not have heard of. I've been using Lua for quite some years now. So long I can't even remember how I came across it. Lua was designed to be simple, small, portable, fast, and easily embedded in applications. And I think these are quite unusual things about a language. Most languages are designed to be cool, indented, easy to use, object-oriented, functional, and all sorts of other things, but not small and fast and embedded. And part of that comes out of the history of Lua. Lua started back in 1993, in between Ruby and Python. So back in the old days, in Rio de Janeiro, which is not a place normally known for programming languages. I think it's the only programming language in widespread use that came out of a developing country. And other than Ruby, one of the few programming languages that came out of somewhere other than Europe and America. It was designed to be simple and portable and fast at the time, partly because Brazil had weird policies around restricting imports, so they had a lot of really old and slow computers at the time. And it had to run on all of these strange computers that they had, and it wasn't designed just to run on one system. It's still run basically by the same team in Rio. It's an open source project. There are major releases every few years and point releases to fix bugs every time, occasionally when there's bugs, every 6 months or so. And it's really a minimalist philosophy. It's really about giving you methods to do stuff and not lots of stuff. But it's a modern, dynamically typed language. It's got everything you expect, first-class functions. It's got all, it's not it's not cut down in the sense of being terrible. You can build it just with an ANSI C compiler. I mean, and that's an ANSI C compiler. It doesn't require even C89 support, and people run it on all sorts of things because of that. I mean, it's the only programming language where I've come across queries on the mailing list about running stuff on non-ASCII character sets, epic and stuff like that on the mailing list, and it's fine as long as your C compiler actually does what it's supposed to do. Also with C, half the language spec is basically the API for interfacing with C, both for embedding C in Lua or for embedding Lua in C. You can embed them either way around or both ways around, which is a simple stack-based interface which works really, really well. And it's small. I mean, I compiled it the other day just when I was writing these slides to check, and a sort of standard statically linked build is about 137K on this machine here, x86, which is less than 5% of the size of the Python or Ruby or JavaScript compilers that I have on this machine. And that's just that's everything in one executable. Part of the reason it's small is they take features out. Lots of features have been removed from the language over the years if they didn't really work, or if there was a new, better way of doing things. So compatibility does break, but that's only every few years when the major releases, and you can always use the old version if you don't like it. I mean, people still use Lua version 4 from back in the 90s or early 2000s or so if they still want compatibility. There's only one complicated data type, the table, which is basically hash table array combination, and you can build everything from that. It's one of the fastest interpreted languages, I think, partly because of the size and simplicity, partly because it doesn't have lots of weird special cases. So if you look at the benchmarks, it's really, really quick compared to other programming languages. There's also a JIT compiler for it if you want, which also has a hand-coded assembler interpreter for various CPU architectures. The language itself is MIT licensed, so you can do what you want with it. the source code's readable, which so if you want to change something in the language because it doesn't suit you, you can. And the language is really easy to learn because it's simple. There's also, it's partly the other reason it's easy to learn is that there's this book, which is, this is the old edition, which is written, basically the Roberto, who writes this book, writes it alongside each new release of the language, and if he can't explain the feature concisely in the bit of the book he's allocated, he'll change the features so it's explainable. Because if you can't write it down and document it, then it can't be right. So he was telling me that when I saw him that yeah, he basically the first edition it wasn't written like that, and when he was writing the book, he was like, why did I make the language like this? It doesn't make any sense. So the new editions basically get written alongside. The older versions are available online for free, or you can order this from your local bookshop. And it's also one of the best written introduction to programming languages books. It's kind of, you know, Kernighan and Ritchie type standard of the sort of classic books about how to do everything. And this does cover the entire language spec, everything in it. There's nothing that's not in here. And it's not, this is properly explained, not just a list of functions or anything like that. What's Lua used for? I think there's a sort of sample. Games was one early use. Lots of people trying to do scripting in games, real-time stuff. There's a new niche in terms of high-performance networking type stuff. Cloudflare are big users. They do multiple gigabits a second through that. Adobe Lightroom's written about 85% of it in Lua, and they have a big Lua team working on that. It's in all sorts of software for scripting. Nmap, for example, all the scripts in Nmap are written in Lua, and that's lots of people's first introduction, other than if they're not World of Warcraft. The user interface for OpenWRT is all written in Lua. The web interface is, and so on. So there's lots of things that you don't generally see that are written in it. So it's a kind of bit underground, really. For embedded systems, number one, it's small. I mean, that really obviously makes a big difference. And you can make it even smaller than that, sort of 130K if you want. You can take out the parser and just use the bytecode, which obviously helps. Another reason is it's always been built, the number type in it, it's standard in most implementations, it's double, but you can change it to an int if you want, or any size int you want. And the language, you just change it in the headers and compile it, and everything will work. So for things like microcontrollers, you just run an integer-only version, and that's just fine, and that's expected. And obviously, your maths functions will just be not compiled in, but everything else will just, you can't calculate cosines very well with just integers. But if you don't need that stuff, that's fine. Because it's simple, it runs fast, and it's portable, so you can run it anywhere. So the eLua project is basically a project for Lua microcontrollers, but it's not a different version of Lua. It is just Lua with a framework around it in order to give you the other bits you need apart from the language, i.e. the bit that actually makes the system run, embedded libraries and so on, which has been basically around since originally 2005. We actually have one of the principal authors just over there who has just recently moved to the UK, and it's very nice to see him. So that's Bogdan. So say hi to him, and he will be able to answer all your questions. There are reports in the repository for ARM, lots of ARM boards, AVR32, and there's a bare metal i386 port that you can actually boot either on bare metal or on a VM, which is a whole operating system rather than just cross-compiling running. You can actually just boot it up as an operating system. Again, it's MIT licensed. Most of the stuff in the Lua community is MIT licensed, like the language. It's very much an MIT licensed community, so building it into commercial products is not a problem. I mean, how small are we talking about? Small for microcontrollers. normal Lua needs about 20k of RAM to start itself up on a normal desktop machine to actually before you do anything. eLua has an optional patch that basically moves most of that 20k out by making all the built-in modules read-only, and you can store them in Flash. And also some low memory stuff, which will do garbage collection when you're trying to allocate and things like that. So really, it gets down to effectively almost no memory overhead, RAM overhead for the actual language. Obviously, you need memory to run your programs. But the language is basically not using up all, a lot of memory, and you could basically, what you need depends on what you actually really need to do. It's obviously, if you're really in a memory constrained environment, then you've got to make compromises of things, and because you can interface C and Lua very easily, you can always do stuff in C rather than in Lua. And obviously, it is a garbage collected language, but it depends how much garbage you generate and how much non-garbage you generate to fill your memory and so on. So eLua comes with lots of libraries for common microcontroller stuff. So basically, talking to hardware, low-level hardware stuff and higher-level hardware stuff. Actually includes a whole TCP/IP stack based on micro IP or whatever you want, and there's even a web server available. But basically, most of the stuff that built into it is, I2C and that kind of lower level stuff, timers, those kinds of hardware things, and low level stuff to do with interrupts handling, things like that, which tries to be as cross-platform as you can reasonably be, given that the hardware is completely non-standardized and things are not really the same. And obviously your code, if you're trying to make it cross-platform, will have a whole lot of configuration variables in for your different types of machine, because there's a lot of configuration for things that are non-discoverable and so on. So, but it's helpful stuff that's kind of easy to use. Lua itself, I was going to show you, this is actually the entire syntax definition of Lua. I thought I'd show it to you because it fits on one page. So if you've memorized that, it's really easy. As you can see, it's a small language. It really is not a complicated syntax. Here's your very basic hello world to flash an LED program, which basically PIO is the programmable I/O interface for eLua, and TMR is the timer interface, and these constants, the pin numbers on this particular board here, and you can run this program, or similar. There's a slightly more complicated one. We can just run that. That's how do I non-full screen this? Thank you. I've got it. I mean, it's being a bit weird about giving me a terminal back. Let's see if I can. Okay, so wake up again. So here's basically, this is running on a little cheap ARM STM32 board, which I've got connected to the console, which is one of the supported targets and is used to flash. This is the cheap one that costs a tenner. You connect to the serial console, you get a terminal which is not the Lua programming language. It's basically a little shell interface that lets you do stuff like save files and load files and so on. You can just go straight into Lua if you want, and you can do stuff air, but we can do maths. If we just download our, we can just receive a program over X mode. Our flashing light program, and we get our flashing lights on here. So you can. We'll talk about ways you can execute stuff as well as that. Let me just switch back to the. Hold on. No, what? Yeah. So basically, you can either just run stuff in the interpreter, but the editing interface is not very nice. So you can do file transfer like that. There's an RPC from the desktop module. Some boards like this one will just have an auto execute from an SD card because this has got an SD card. Some people have written editors in Lua that run on the board, so you can sit there and edit it in the editor. There isn't USB host file system access for anything that's right now, which is a kind of pity. But so you've got a kind of choice of ways to interactively run code. I think the file transfer seems to work for me pretty well, but it depends. I think it depends what sort of debugging you really need to do, and what, I don't know. I'm not sure how do you usually debug stuff or work out how to. I'm not debug, but you don't write no bugs obviously. But I mean, how do you normally interactively? What's your preferred?
I generally use the remote file system. Have you ever tried that?
Sorry.
Have you ever tried the remote file system?
No. Okay. Oh, okay. So there is a remote file system option. Okay. I should. For production, obviously the thing to do is effectively to just build your code into the Lua build. And just flash the whole thing. You can basically statically compile Lua and Spike code, link it into your C program, and just execute it from there. So that tends to be the easiest thing to do, and then you can use a mixture of C and Lua code in your production code, and just flash it all down as one image and run that. I mean, Lua and C are kind of designed to run well together, and it really, I guess one of the reasons I kind of got interested in Lua, started using Lua in the first place, I guess, was that I was a C programmer, and the kind of idiom of mixing C and Lua came quite naturally to me, and I think for a lot of embedded applications, you're going to do that sort of mixture as well as just writing stuff in pure Lua. Though, I mean, you can perfectly well write high-level device drivers for things like that, actually in Lua, not in C, and just write most of your code, actually in Lua. There's an open hardware board, which I've got one off here, which you can come and have a look at, which ships with eLua from a company called Simple Machines initially. You can download all the designs for this. It's an AVR32 based system with an external RAM chip, so it's actually got those 2 meg of RAM and an SD card and so on. And it comes with a lot of modules. There's an Ethernet module, LCD display module, and various other ones. And yeah, all entirely open hardware, and also it comes with eLua shipping out of the box, and a bunch of other options. So that's one of the things you can use if you want. The Lua community is smallish compared to other programming languages, I suppose, but and they tend to be quite well hidden in places like games companies and embedded systems companies. And I think one of the reasons I organised the London Lua Group was to try and get these people to talk to each other more, because embedded systems people are quite hard to drag out of their work, and games people are equally unsocial unless you force them. So Yeah, it's actually been quite good, but it's quite I mean, we have quite a few people in our 160 odd people on the meetup group now who come along, and I should organise a meetup soon. Eclipse is doing a lot of open source work, started doing open source work around embedded Lua in particular, and they're kind of they've got a few projects in there, and people are starting to cooperate more through them. Sierra Wireless in particular started working with Eclipse, and they use quite a lot of Lua-based software in their stack. So there's a kind of open source thing around Lua and Eclipse, which is quite good. Here's a list of links to some of the projects, really. Ah, that's exactly the end of my presentation.
Well, that says it's time for some questions. And I'm sure we have some. Mike.
We had a presentation, first heard of Lua at Reading Geek, and the presentation was about promoting Lua as a good language for students to learn as an introduction, as a step up from things such as Scratch, so for much younger students. I don't know how that has progressed since.
I think it is a good language for that. I mean, we have a bunch of kids who come to the Lua meetups who have been using. I spent some time in the summer, and they're doing robotics stuff, and we've been working on some Lua stuff with them. And I think it needs some more material to help people get started. But I do think it is a good language for that, and I'm going to spend some more time working with these kids, because they just started coming along to our meetups, and because their teacher had decided that Lua was a good idea, and I think it's definitely a good option. It feels more like a real language than Scratch. I think I found Scratch quite weird as a programmer, and I don't know that the kids. I think it's quite good right at the beginning, but I'm not sure. I think Lua is a good language that you can get your head around and remember, because I think kids find Python quite syntactically hard, because there's a lot of it. But I think, it definitely needs more materials to help people try that out.
So it sounds as if it's available and embedded, then such things as the robotics area is a strength.
Yes.
For it, which,
There's because there's a Lego Mindstorms Lua pulse as well, and various other.
So your flashing LED example was a kind of continuous loop Lua. Can you do things like an event is raised in my C program, call a Lua function, and then get back out again? Yeah. I mean, the Lua C interface and the C Lua interface are really straightforward. You can do it either way round. So it's it's just a few lines of code to push arguments onto the stack, and then they appear on the other side. And you can inject C functions so they look like native Lua functions as well. And you can call in both directions at the same time. I mean, you can have callbacks going both ways. And Lua also has coroutines as well, so you can do kind of asynchronous pseudo, effectively user-space stuff that looks like threading by using coroutines, so you can have multiple threads of control.
Another question there.
My question was just going to be, what was the story of threading I/O, reflection, and introspection? But I think you just answered all of that.
So I'll ask a little follow-up, which is interrupt handling. So can that be done?
Yes. You're probably a better person to answer this question though, on how the interact.
Right, so yes, it can be done. Basically what happens is, once the CPU gets an interrupt, it is queued in a data structure that is shared between C and Lua. And to actually interrupt the Lua program, it uses an interpreter feature, hooks. The interpreter lets you add hooks in the code as a way, for example, to debug it. So after you activate the hooks, the hook code looks at this queue and sees that it has an interrupt handler, and then interrupts the regular for program and calls the interrupt handler. It's not exactly real time,
No, there's no actual. No, because it's not actually allocating any variables during the loop, so there's no actual.
There's no structures allocated to all method lookups or numbers or they're created.
No.
It would be that particular example in eLua wouldn't take RAM at all for any of the tables because of the tiny Lua batch. So all the tables would be basically hard-coded in Flash.
But
But when you make a number 5,000 or something, is that creating a number?
If you put a constant number in, it doesn't get out. If you stick it in a variable, a local variable, then it will be. But it's the constant number will be allocated in the bytecode because it's bytecode compiled. So there won't be an allocation at that point of view. I mean, generally, it'll only do allocation if you actually basically create a complex data structure like a table or add something to it or create a new string or something like that. But it won't generally it won't do any allocations just for a function call or just for a numerical, just calculating a number or something like that, because that'll just happen. I mean, calculating an expression will happen on the C stack in C, and then it'll get, if you're not allocating sticking it into a new variable, it'll just be reused. So it's pretty friendly from that point of view, and you can, the behaviour of it's not. I mean, the language is simple. You can actually understand what it's doing. You can read the bytecode and understand, or read the source code of the language if you want to know where stuff's going on. But it doesn't have surprising structures that do things you don't expect, unlike a lot of other languages where there's objects and stuff that do stuff that is not immediately obvious. You can see everything that happens, and it doesn't hide it from you.
Okay, we're going to get down to the pub later. That's one of the reasons I'm standing here trying to move things along. And at the pub, we can have in-depth conversations right down to the bit level. So anyway, so thank you very much.
Everyone.